Okay, good day everyone. Welcome back sa ato ang lecture. So we'll be continuing with our discussion. So we are done with chapter 1, which is the basics and orientation of the programming language that we will be using in this course. And that I would just like to refresh you a bit on what this course is all about because previously nahuman naman tao discuss sa katong MATLAB, right? And it's just as actually we just barely scratched the surface on what MATLAB into on what MATLAB is in totality siya. So anyway, katong i-discuss na to last lecture video, those are enough actually to proceed kung unsa ato ang dapat mabuhat for this course because this course is not entirely MATLAB. So MATLAB is just a tool for us to solve problems wherein we can understand and describe phenomena in a much meaningful and somehow quantitative way. So again, I would like to reiterate that this is about physics, ang kaninga course, and some chemistry problems maybe if because chemistry and physics are close to each other man na siya tapos napagi math actually kanang tulo. Okay? So before ang physics yun actually is categorized or classified or grouped so to speak into two distinct fields. So we have the theoretical physics, which is focused on developing and applying theories with emphasis on mathematics and rigor. So we have theoretical physicists or mathematical physicists. The likes of Einstein he is a theoretical physicist. Richard Feynman, Paul Dirac, those are one of my heroes, mga idols sa physics. And also ang modern karon nga scientist nga ako ang giganahan gyud as a theoretical physicist is si uh, Edward Witten, kana sila si Michio Kaku and Brian Greene, kana sila mga mga proponents sa string theories. Okay, so as I've said, those are what we call theoretical physicists na belong sila sa theoretical physics na field, and there are also people nga naa sa experimental physics. So wala may ginaingon nga mas dindot ang theoretical physics, mas maayo sila compared sa experimental. Well, in fact, they go hand in hand. Okay? Because bottom line is ang physics yun is experimental yun siya nga science. Okay? And theoretical physics nag-exist na siya just to give to make sense of something nga kung saan ma-observe. Okay? Kaya ang physics mo, ano man na siya, mo describe siya quantitative in a way nga para ma-explain siya and also that quantitative statement of any observed phenomena will be used in the future for forecasting purposes. Okay, diha man ta maayo po we do forecasting, we do prediction based on what's on what's on hand. Okay, unsay available nga mga information or data. But in so originally we have these two theoretical physics and experimental physics, but recently, so when I say recently, uh, back in the early pa yun siya, let's say late 1980s maybe, or in the early 90s, gasugod na siya diha. So during this period, na ay ni-emerge nga bag-o nga classification or category sa physics, and what we call that one as the computational physics. Okay, so computational physics kay very useful siya because with the use of computers kay diha man nga mga era, di ba, diha nga era or generation ni emerge ang computer, so diha pod misugod og develop or progress ang computational physics na field. And computational physics uses computers, powerful computers to solve um, maybe difficult problems and problems nga dili na siya makaya og solve by hand. That's why we need computers to solve it efficiently and mas fast pa siya. Okay. So if we have, say this is for theoretical, then naatay experimental din physics. So in between naa diha ang computational. Okay. Computational. Dako kay ni siya og scope ang computational physics. Computational physics are very useful sa experiment because in experimental physics, before they can do an actual experiment, sometimes ang experiment ng good is, actual nga experiment ba is sometimes dangerous siya, kay let's say mag-involve siya very very high temperature or very very cool temperature, and they are not even sure if unsay mahitabo bitaw, if feasible ba siya, or something like that. So before they can do an actual experiment, so computational physics can come into the picture and simulate. Okay, i-simulate nila kung unsa ang dapat nga mga parameters dapat in such a way nga mahitabo ang experiment, and also safe pod siya. So gamit kay diri ang computational physics. Okay, let's simulation on, let's say unsay dapat uh, nindot nga current for a specific device nga imong i- i-create, something like that. So nakay electronics ng mga part, and then i-simulate nimo daan if unsa ang iyang mga interplay nga pwede dapat mo arise based on that. So nakay simulation. And also sa theoretical tabok sa siya diha because there are problems in theoretical physics, or more, maybe uh, several problems na mga interesting kaayo nga involve sa equations nga dili na siya makaya solve. So wala nag-exist na exact solution. Okay? So diha na mosulod pod ang computational physics because it can provide solutions, pero in a approximation lang siya, but good enough kay makaano naman siya, makahatag siya og solution nga dili ma-provide sa kaning theoretical aspect. Okay? So very broad ni computational physics. Naano siya sa naano siya sa computational bio, tapos siya sa computational science, and all aspect computational sa aspects sa sociology, even political science. So, very useful ni siya. So, muna ito ang track karon. Just we'll just try to look into the overarching theme sa computational physics. So we'll not be able to touch all of them, but some of them kay magamit na do siya. So for computational physics, we need a working knowledge of numerical analysis. So diha ta mosulod sa kalinga course, so you will be introduced with a numerical analysis, and yes, computer programming, MATLAB atong gamiton kay masayon siya nga language, and efficient siya at the same time daghang kay available ng mga resources na. And all in all, bottom line good, or at the end of the day, the goal is to understand the physical universe, whatever it takes. Kung sa imong tool nga kailangan mo, you need mathematics, you need to do experiment, or you need to use computers to simulate. The goal is to really make sense of the natural phenomena or understand what's going on in the universe. Okay? So language fluency is not required. So dili required or dili assume ang nga fluent ka dito sa MATLAB. You will be able to learn MATLAB as you progress in this course. Okay. So take note also that this course is not primarily concerned in coding, but more on performing calculations. The coding skill will just follow later on, okay, as you practice. So as I've said, to that extent, once you know how to think computationally and numerically, unsa pa nga language, makaya gina siya og translate. Once you have a problem, you break down that into pieces, you make an algorithm out of that, and then from that algorithm, pwede na siya ma-apply sa unsa nga language, okay? Kay usa ra man na ang theme sa tanan language, okay? Lahi na siya og syntax. So any language would be suitable, but for our case, we'll just stick with MATLAB. Okay? So nahuman naman mo aning introduction sa MATLAB, so we'll skip ana. So we did a little bit of calculation sa katong previous na to nga lecture or video, right, about calculating the average of two numbers. Okay, so for this chapter, we will be also doing calculation, but this time is centered on roots and function. How do we find the roots of the equation? So this problem is a very elementary. So you've actually encountered this one during your high school, maybe elementary. So the idea is to find the roots of a function. Okay, let's say f of x equals x squared. Okay, or x squared plus 1, like that. So unsay dapat value sa x na para ang kaning whole thing would be equal to 0, right? So para man na ang idea sa finding the roots, and then you have your equation dayon nga x squared equals 1, right? So x equals plus minus I. Oh. So that problem appears in many books sa mathematics. It's as simple as the one that I gave kanina, that example, to a much more complicated problem na appears sa physics here. Okay, so finding the roots of a function appears in many problems in physics, specifically in quantum mechanics. Okay, so ma-appreciate nyo na siya when you go into quantum mechanics, but di ata mo touch diha. So for instance, you have this very simple equation. You have f of x f of x equals x minus 3. So if you want to find the zeros or the root of the function, meaning for this equation, unsa may value niya dapat sa x para ang whole thing would be equated to 0. Okay, that's why we have this. And we can simply rearrange that one. I-transpose mo ang negative 3 sa right side of the equation, and you get simply x equals 3. So which is the solution? Okay, so if you substitute 3 from this equation, of course, it will give you the answer 0. Okay, so check here. So the solution is at x equals 3. Okay, how about another example, or much more complicated than that, or advanced, wherein nonlinear na siya nga mga equation. So example of a nonlinear equation is this. F of x equals cosine minus f of x equals cosine x minus x. So what do you think is the solution of this equation? So unsay dapat value sa x so that the whole thing would be equated to 0. Finding the zeros of the function, or the root of the function. Okay? So let's say i-try ninyo siya solve. Actually, di ninyo siya ma-solve because there is no solution, exact solution na nag-exist. Gani. So wala na siya exact solution. Okay? So that's pretty difficult to solve. So finding the zeros of this equation does not have an analytic. So wala siya exact solution na imo siyang i-derive ito. However, one can find the root by looking at its plot and determine the point it intersects. Interesting. So saan mo na siya? So let's say ato i-draw. So Okay, this is your x-axis and your y-axis. So, dapat i-draw nimo siya. Let's say, itong f of x, balik ta. We have cosine x minus x equals 0. So, if imuha na siyang i-rearrange, you transpose the negative x to the right-hand side of the equation. You have cosine x equals x. Okay. So, asa man dapat nga point sa x nga mag-intersect sila ba? Meaning, kung sa value sa x nga kani siya o kani cosine x mag-equal sila. Okay? So, i-plot nimo ang both side of the equation. So, this is f of x. Say f of 1 na x, f of 2 x. Okay? So, your f of 1 of x is cosine x, and your f of 1 of x is x. So if you plot the f of 2, f2 of x. So if you plot this one, can x, can I see, that's just a straight line, right? Can straight line naman na siya. Y equals x. Right? This one is y equals cosine x. So y equals x is just a straight line. So straight line. Passing to the origin. So inana siya, ihang graph. Okay? So this is, lahit na lang na, lahit na color. Wait. Okay? So this would be f of x equals x. So it's a straight line na siya. And then if you try to plot also cosine x, so unsay itsura sa cosine x. Okay? Sinusoidal man, di ba? It's a wave. Okay? So ang itsura niya would look like this. Say this is 1, this is 2, this is 3. So would look like this. Right? So from this graph alone, makita mo asa siya nag-intersect, right? And that intersection, the point of intersection is the solution of your equation, okay? So kung saan na siya nga point, that's where nga nag-equal sila. Nag-equal sila. Ang cosine x equals x. Kani siya nga point. Okay? So this is just one way to do it para makuha nimo ang solution is to graphical. Okay, makita man nimo nga oy automatic naadara ang solution. So we can plot that one using MATLAB. So nanata sa to ang MATLAB. So let me just close this video para dili occupy siya space. Okay. So how do we do that? Mag-create ta og script. So new script. And then ato siya i-save ano. So let's see, save na to siya din. We call this one as okay. So this is first, this is example 1. So para maka-plot ta sa ato ang duha ka function, we need point sa x, right? Kailangan tag point sa x para makakuha tag mga point sa y because it is an x and y coordinate. So taken from previous lecture, we can generate points along the x-axis by using the function in MATLAB built-in called the linspace. So let's say from 0 to 1. Assuming lang nga ang solution is makatagna kadaan ba or maka-guess ka nga. Okay, I have a good guess na naagi siya around 0 to 1. Tapos we'll find out if i-graph na to if naadra ang solution mag-intersect siya. If wala din ang solution between 0 and 1, so wala mag-intersect, then we need to increase our range. But for that, we'll settle with 0 to 1 and then 100 points. Okay. Then we'll plot our first function. Our first function is, let's say, cosine x. Right? And our second function is x. So in this way, for each value of x from 0 to 1 containing 100 points, so distribute ng 100 points between 0 to 1. For each value of x, na siya value sa y. So i-calculate niya, let's say from start. Cosine 0, na siya value sa y1. So vector ni siya o array. Kaya ang x nimo kay vector man na siya or row vector. Then we have cosine, let's say 0.1 ang sunod. So unsay value sa cosine 0.1, i-store niya sa second value and so on until maabot siya sa point sa from 0 up to 1. And then also for x. So we'll plot this one. We'll use the plot function. So ato siyang i-overlap ang duha ka function, the y1 and y2. So x tapos isa kay y1 and then butangan na to og coding para malibog unsa ang which is which na graph. So the first graph will be, let's say, color red. And then the second graph, so x, y2, the second graph will be in color blue. I hope okay na mo sa akong color choices. Okay. Then we'll put some sensible title. So the title is f of x equals cosine x minus x equals 0. Okay. And then we'll put also labels x. We call that x. And then the y label and then putang pudog legend. So automatic na siya. Ang first mo nga ibutang nga title is mo correspond sa first na plot and then the second legend will correspond to the second plot. So the first plot will be f of x equals cosine x comma f of x equals x. Okay. Then we'll run this one. So we have your command window here. I'll type the file name, which is this one. So hopefully sakto siya. Okay, so that's it. Have your plot. It has a title here, the labels x and f of x, and also the legend with the corresponding color for each plot. For the red, we have cosine x, and then blue for the f of x equals x. So notice na nag-intersect siya. So okay ra ato ang guess na from 0 to 1 ang interval because from that 0 to 1 interval na diha ang solution, okay, which is found to be, so if you hover nimo, I don't know sa uban nga version pero sa 2020 nga version is automatic na siya nga pag i-hover nimo na siya diha. So it's around 0.7374. Okay? So ang solution is 0.7374, meaning if i-substitute nimo ang 0.7374 here, that would give you 0. Okay, that's the solution or the root or the zeros or the zero, okay, isa ra, zero of the function. Okay? So, back here. So, mani ang ihang graph, and the solution is found to be, it's approximate siya around 0.75. So, this is okay. Kaning graphical nga method, quite okay siya and doable. Since ang problem kay mag-require naman siya usa ka solution, di ba? Meaning usa ka zero of function. However, kani siya nga trabaho, this job gets too tedious if you are dealing with finding not just one root, maybe how about lima ka root or napu ba? So kano siya nga scenario nga mag-graph ka tapos mata-matahon nimong tan-aw ay ang efficiency mosamot kagamay. Okay, mo decrease siya rapidly. So in this case, we will really have to employ numerical root finding. Okay, anong natay technique na buhato, we need to devise an algorithm on how to find the root of a certain function. And we can do that in MATLAB. So we will both explore a basic root finding and see examples later on magamit ta sa MATLAB na actually nanay MATLAB built-in routine. But before that, we'll try to understand and analyze what's the existing root finding ng mga algorithm ang gigamit and how did they construct it or do it. Okay? So the first method is the bisection. From the word, ang pinakauna is from the word bisect. So ihang itunga-tunga niya. Okay? So if you have a let's draw an axis. Okay, so if you have a function that looks like this, okay, oh, lahat na lang ang color para na distinction. Sinakuha na nga function. I don't know kung saan na siya nga function. Basta kay na iyang graph. And take note nga, it crosses at one single point sa x-axis, right? So, wala siya ang actually yung zeros or solution niya. Okay? But how do we find or determine the zero of that particular function? So, kung sa dapat ang value sa x niya nga ni cross siya sa x equals at y equals 0, okay, along the x-axis. So that's why 0 siya, because this is f of x. So this is f of x. We say of any function. So let's say f of x in general. So if we equate that to 0, so unsa dapat ang x niya din. Okay, this is f of x, 0 siya. So I'll be using the bisection method. Sa bisection method, sa'yo na siya. I-divide lang nimo ang imuhang function. Imo siyang i-trap ang function kung asa ang root. So let's say na kay interval din na. And that interval is, let's say, xl and xr. This is for left, this is for right. So, of course, ang pag-choose nimo sa interval, it must be nga nasa sulod ang imuhang root, right? Kung asa ang imuhang asa dapat ang solution or 0. And one way to determine if nasulod ba gyud sa interval is to have a check. If if f of x sub l times f of x sub r is less than 0, then the root is in the interval. XL, XR. So, sure ka nga naa dira ang interval. So, I think make sense na siya, di ba, nung kani ang ihang equation. Okay, because if you substitute XL, you get actually the f of XL, di ba? So, for this, muna siya ang XL, muna siya ang f of x sub L. for the XR, mo ni siya ang iyahang iwi. Oops. So, mo ni iyahang, assume na nga straight na siya. So, this is f of XR. Okay? So, sa f of XR, ang value niya is negative, right? Kaya naman siya sa ubos, sa y. Ang f of XR is positive. So, if ana gani ang case, negative, ang isa positive, i-multiply ni mo na siya diha, the result should be negative. So, nasa sulod, na-enclose ni mo ang root within that interval. But if it so happen nga yung interval is naa dinhi, say naa dinhi ang interval, so the f of xl ana is negative, ang f of xr niya is negative, so i-multiply ni mo siya, becomes positive. So wala siya ni suit sa imong condition nga should be negative. That's why kung positive, wala gid diha ang root. Okay? The same po din sa PCAS. If naadara ang interval, pulse mo na siya positive. So, there's no way nga ma-negative ang imong product sa f of xl and f of xr. So, that settles the concept kanong kani siya ang imong condition. Okay? So, that should be the condition. So, once nga nakahibaw na ka nga naadiri ang root for this particular interval xl and xr, next is i-determine nimo ang midpoint, okay, between that xl and xr. So how to do that? Simple. You have xl plus xr over 2. So sa kaning particular nga case, say ang interval nato is naa dinhi, ang midpoint is naa dinhi. Okay? So the midpoint is there. So imo na pong evaluate dayon. Asa kaha na enclose ang solution between XL and XM or XM and XR. So this is XL. This is XR. This is XM. This is our midpoint, okay? XM. So dali na ito makita kay graphically makita man nato nga naagid between sa XL and XM. Okay, wala sa XM and XR ang solution. But sa computer, di ba siya kakitaan na? So we need to do another test. Kailangan na po nato i-multiply. Multiply na po nato ang XL and XM. If less than 0 gali na siya, then naadira ang, right? I hope you can follow. So naadira diha ang imuhang solution or ang root. Or otherwise, naa sa XM, XR. Naadira ang solution if less than 0. If okay. So if this is true, so mabag-o na po ang imuhang interval, right? So your new interval would be, so set XM as your XR. Sa kanipod nga pika, set XM as your XL. So I hope na follow ra. Kaya inani man na siya. Sa kaning nga case, if na-add diri sa XL and XM ang imuhang ang root, so the new interval would be from XL and XM. Okay? So from this, pangitaon na po din mo ang midpoint and so on. Kani po din if na-add diri ang root, pangitaon na po din mo ang midpoint. So mubalik-balik na po ka sa imuhang, actually repeat, sige na kag tunga. Balik atong ipadayon na siya. We have XM is here. So kay mao naman ta nga based atong calculation or condition nga naa diri ang root between the XL and XM. So omitted na to ang sa pikas nga half. It's like atong divide and conquer bitaw nga example nato sa C, katong makita tag pangalan sa phone book. tungaon ni ba ang libro og katunga. If naa dinhi sa pikas ang gipangita nasa wala, throw the right half and the other way around if mao ang case. So mao po na dinhi. So we have XL and XM. Find again the midpoint. Kasi ang midpoint anin duha is naa dinhi. So i-test na po nimo asa na po ang root between the XL and the new midpoint ba and so on. So since naama siya dinhi, this is your new interval na po kana. Pangitaon na po nimo ang midpoint hatod sa ma-zero in gid niya, makuha gid niya ang solution. Okay? So how do we know if ang solution is mauna na siya? So all you have to do is calculate the difference between XL and XR. Ito interval, right? If gamay na gani kayong interval, let's say mo set kag value nga around less than or equal to epsilon. Epsilon is around 10 to the negative 8 ba, depende kung sa kagamay. Then, if ma-reach na siya nga point or nga value, kaning epsilon, then mukwit na kasi mong program na, uy, nakuha na nako ang solution. So you can see the idea. So you keep on repeating, cutting into half ang interval until such time nga makuha nimo ang sakto nga accuracy, then you display the result. Okay? Wherein naa sa x sub m ang solution, ang imuhang root. So, iterative man siya. So, namo idea nga, mogamit din ni og loop. Pwede for loop or while loop. Na for this case, while loop ang best nga loop nga gamiton. So, that's how to solve a problem in finding the root. So, first, we have to construct our algorithm. So our algorithm is this. Find the x and r, xl and xr interval such that ang iyahang product sa katong f of xl and f of x sub r is less than 0. Okay? Then secondly, magamit ng ka og loop or magamit kag loop, and that is while kani nga interval xl og xr, absolute value of that, while mas dako pa gani siya sa imong giset nga value, so you keep on cutting your interval into half. Okay? So this is epsilon. Epsilon. So while that is greater than epsilon, you calculate the midpoint, okay, which is xl plus xr over 2. And then, once you have your midpoint, imo siyang i-calculate pud ang katong if katong product f of xl times f of xm is greater than 0 gani, is less than 0, meaning naa dira ang solution in between sa xl and xm or sa katong midpoint. That's the case, you set xm to xr. So ang midpoint mahimo ng bag-o nga xr. Okay, dito naman ang next nimo nga interval, wala naman tong sa other right half. But if ang case nimo if fxm and fxr is less than 0, meaning naa sa right pod, then you set xm to xl. Okay, muna siya ang bag-o nimo nga left na pod. And then repeat. Okay? Repeat A. Okay, loop mo na siya. Repeat A if XL is greater than epsilon. Iyaha mo na kuan, i-evaluate. So if di na gani siya ma-satisfy kani siya nga condition, meaning naabot na ang accuracy, then you quit. If satisfied, if root found, print, right? You print the result. So that's how you solve the uh, finding the root of the equation or the function using the bisection method. Side na, di ba? I hope na ma-follow na siya. So, next is we have your algorithm with you. I-translate na dahil mo siya into computer code in such a way nga ma-solve na siya sa computer kay nag-involve man ni siya og looping. If imuha siyang bana ay siyang imuha siyang sa tawagan na itinamban by hand with pag-calculate would take you let's say one day, then entire day mahurot na siya imong oras. But we just have to instruct the computer based on this algorithm, and then the computer will spit out the solution in just a matter of seconds or a fraction of a second, provided that you have uh, inputted a correct algorithm and code, of course. So that's for the bisection method. So this is the typical, kani siya is dili pa ni siya code. This is just pseudocode pa na siya. Say instruction on what to do. So ang pseudocode is not the actual code, but it contains information na siya wherein pwede siya ma-apply sa lahi-lahi nga language. Okay? For this case, atong i-apply sa MATLAB. So, as I've said, remember to think first, of course, and then you code. So, we've done our thinking kaganina wherein unsaon day pag-solve unsaon pagkuha ang root sa solution or ang zero of the function using bisection method. So, inato siya na-analyze na nato. And that's why we have come up with this pseudocode. And of course, give your variable meaningful names. Di lang kayo bisan unsa nga mga variable names. So let me. So this is the program, the main program sa imuhang root. So take a look at this one. This is a function. Function na siya nga word. So this is technically a function nga file named bisection. So naa siya ang first part sa program is nag-initialize siya. So muna ang interval niya. X initial or X final or XL and XR. So nag-start siya from 0 until ang X final niya or XR is pi over 2. And then once nahuman na siya initialize, kaning initial and final nga mga value sa X or kato interval, i-input nimo siya sa bisect na function. So nag-create ko bisect na function wherein the bisect function is naa siya input, right? This is the input, and muhatag siya output which is stored in the variable name root. Okay? So provided nga makuha niya ang solution. Once na makuha niya ang result sa root, i-store niya sa root, i-print dayon ang result. So naka-print f din diha. So 3 parts lang ang imong program. We have initialize, then we have calculate, the calculation part, and then print. Okay, the printing part. So this is the remaining part of the program. kay nagkani siya nga this the main program is actually bisect nga function, right? So this is the definition or pag-define sa bisect nga function. Tara, bisect. And then nagamit po siya og kaning function nga f of x. So ang gibuhat din is pwedeng padakuon. So the first part of the program is you prepare your program for looping. So take a look at this. Ang input niya is katong initial left and katong right. So you prepare for looping. So nag-set kay initial values. So top of the loop. So kay condition, di ba katong condition nimo is dapat if maabot siya ani nga accuracy, mo stop na siya og loop. So loop through the body as long as the bracket is too large. Katong epsilon. Okay? Ang bracket is too large, meaning XL minus XR is greater than epsilon. Okay? And then the body of the loop is katong you divide the interval into half. Determine which half contains the root. If naa ba sa left or naa sa right. If naa sa left, i-redefine mo ang limit. If naa sa right, i-redefine mo ang limit based sa katong algorithm ganina. So once the bracket has been sufficiently narrowed, cease the looping. So stop nimo ang program, quit, and then you print. Okay? So let's take a look at the code. Actually, nahuman naman ni siya og code. Ang mga functions nga kailangan. Ang kani sa MATLAB di ay is, if you have a main function, tapos nagamit siya og function, pwede siya ilahi nimo siya og files. Unlike sa C, bitaw nga. Di ba sa C kay nakoy main, nakoy int main sa C, ana siya diha. Tapos nagamit ko og function, let's say ang function ako is get positive, right? So i-define mo na ko ang function din ni get positive and so on. Tapos this is definite declaration niya. Tapos ang iyang pag-define is nasa ubos, right? You have get positive. Yung sa ang pag-implement. Right? Mo siya C. So sa usa ra siya ka file. If na po kay another function din get negative, add na po ka sa ubos o get negative. So sa isa ka file, na diha tanang definition sa function. Pero sa MATLAB, pwede sa lahi nga file. Okay? The reason for this is if you can create a function nga isa siya ka file, advantageous siya kay pwede siya magamit sa lahi nga program. Let's say imong amigo nagbuhat og program tapos kailangan siya nga function. You can just send to him that single file na nag-contain sa katong nga function. Okay? So let's look at the average bisect. We have bisection, i-print ba, and f of x. Tara. So the main function is this, yung bisection. So muna siya kaganina ang program. We have initializing, call the root finding function, and then the result. Okay, so tulo siya ay duha ka function lang. The first function is bisect. This is responsible for the calculation of and finding of the root. Tapos nag-additional po siya output, meaning pila ka iterations required para makuha ang root. And then from this result, the root and the iterations, this will be fed into this function, the root and iteration, so that i-print. Purpose in life is i-print na ang result. So let's look at the bisect function. So nadiri ang meat and butter sa imong program, kay diri man ang calculation, right? So I have here the error, which is 10 times tolerance. Okay, tolerance is 5 times 10 to the negative 3. So if maabot na siya nga value, kani siya nga error, so mo stop ang imong calculation. So nakuha ni nga while loop. While error is greater than the tolerance, ato the tolerance, 5 times 10 to the negative 3, then proceed na siya diha. Okay? So you take time to analyze this one because this is interesting kani siya. So we have giyon sa siya pag-implement pa into MATLAB code from the algorithm that we had kanina. Right? So the while loop, so good ka ani na condition, and then determine the middle point. And then from the middle point, kailangan ako i-determine ang f middle. So ang f middle is naa siya sa kaning function, where f of x kaning function is given by this, kanina man na siya. Okay? Pag-calculate sa f of x. Okay, kailangan naman na siya para sa imong condition, right? Katong mag-multiply ka aning f left and f middle. If less than 0 na siya or equal to 0, then mag-reset ka sa redefine ka sa imong interval. Else, if nasa PCAS, then mo ni mong pag-define sa katong asa ang new nga interval na pod. And so on. So that keeps on repeating kani siya nga code until error is less than or equal to tolerance. And then output niya ang result as middle and pinakabok iteration. Okay? So, tara ang iyang variable, I have the middle, ibutang niya diha. And then, nagbutang po siya og iterations. So, pila ka bok iterations ang nahitabo. We have iterations equals iterations plus 1. So, until as siya ni stop, dito po tama niyang number of iterations. And then, i-print ba is kana naman siya. It's just the printing. Okay? And if we run that one, we call the main file of the program, which is the bisection, I mean. So we will type bisection, and if we hit enter, so dali na kayo siya, right? Command na yan. So root found at 0.7. Take a look at the result. 0.7393. This is similar, di ba, sa nakuha nato sa katong pag-plot. Wala na. Pero nag-plot man ta, di ba, katong ato i-plot balik ang charot. Tara. Ang solution nato is 0.7374. So somehow, ano sila, kanang close, right? But this is more accurate. This is kaning siyang bisection. Okay? So the same, similar ang result but different ang iyang method nga gigamit. Okay? So that's it for the bisection method. So you can explore this one and use another function maybe na inyong gusto isolve, and then you can find the root of that particular equation using this bisection algorithm or method. So I will be uploading these files for bisection, and then you can download it sa Google Classroom lang. Okay, so that's it for this part. So part 1 of roots and functions. The next part of the video will be discussing on another method which is much more powerful and more efficient than bisection. Still on finding the root or zeros of function. Okay, so stay safe and God bless.